Let's take a look at another example of completing the square using algebra tiles. In this example, I am looking to convert y equals to 3x squared plus 6x minus 1 into vertex form. And we're going to use algebra tiles to help us out. So what I'm going to do first is I'm going to drag out the amount of tiles relative to what I have of my quadratic relation. So I have 3x squared. So that means I need 3 of these blue tiles. So I have 1, 2, and then 3. Then I have positive 6x, which means I need 6 green x tiles. So in this case, I have 1, 2, 3, 4, 5, and then 6. And then I have 1 negative 1 tile. So that's just 1 negative 1 tile. All right, so I've got all of the tiles that relate to my quadratic relation on the right. So just like before, we are going to create squares. Now notice that we are going to create 3 separate squares. So what I'm going to do is I'm going to take a look at this, and then this. So I have my x squared blocks all ready and set up. Now think about it this way. We need to evenly distribute those 6 green long rectangular tiles amongst each of these groups. So that means each group is going to get 2 squares now. Or sorry, 2 rectangles, I should say. So I'm going to group these first like this. So notice how each x square tile has 2 green rectangle tile. The negative 1 tile stays at the top, just like before. We're not going to include it in anything. It'll come into play later on for us. Now, in each of these groups, I want you to start to create the formation of a square for me. So if I take a look at the first group, I'm going to have to, one of them, put them on the side like this. And then the other rectangle, I'm going to rotate. I'm going to put at the bottom. I'm going to do the same thing with my second x squared tile. Again, I'm going to rotate the other rectangle. And then last but not least, do the same thing. I'm going to rotate that other rectangular tile. Whoops. So hopefully let's rotate. All right. Notice here how we have the creation of 3 squares, or at least almost the creation of 3 squares. In each of these squares, we're missing something to complete the square. And that is a single tile that goes in at the corner there. So I'm going to take the yellow tile because I'm adding tiles here to complete the square. So 1, 2, and then 3. So notice here how I randomly added 3 single tiles. I can't just randomly add. I'm going to take away the same amount as well. So I'm going to do 1, 2, and 3. So let's put this all together now. In terms of the squares that I have here, notice that I have 3 squares. So when I start off with vertex form for completing the square, I know that I have 3 squares. The dimension of each square, if you look carefully, the blue tile, this side represents x. This side represents positive 1. So really we have 3 squares that have dimensions x plus 1 all squared. So we have 3 squares and each square has an area of x plus 1 squared. That deals with the 3 squares that we created. Now we're going to take a look at the singular tiles that I've got there. Notice that the singular tiles that I had from before and the new ones that I added, they don't cancel each other out. So in fact, if I count there, I have 1, 2, 3, 4. 4 negative 1 tiles, which means I have negative 4. And so what we've done here is we've completed the square using algebra tiles. This time there is a coefficient in front of x squared. and we were able to represent it visually using algebra tiles.